This is Pre-Calc section 11.1 part 3. We need to look at summation rules and summation properties. Here are three formulas for computing either the sum of the first n integers, the sum of the first n squares, or the sum of the first n cubed. Now if I ask you to do this, this says find the sum from I equals 1 to 5 of just I. That means plug 1 in for I, plug 2 in for I, etc., which means this, you're adding up these 5 numbers. Now, it's not too difficult to add those 5 numbers, generate it, add them up, no big deal. But if I ask you to find the sum of the first 50 integers, you don't want to write all of that out and add those up by hand. But this formula right here gives you a very easy way to compute that. So if I want the sum of the first 50 integers, I let n be 50. So this is 50 times 50 plus 1, which is 51, divided by 2. You can enter that in the calculator, and that will give you the sum of the first, which is 1,275. This is asking you to find the sum of the first 10 squares, because this says for I equals 1 to 10, the formula is I squared. So if I were to try to generate this, put 1 in for I, 1 squared is 1. Put 2 in for I, 2 squared is 4, etc., all the way up to put 10 in for I, 10 squared is 100. Same thing, do you want to add all of these numbers up, or do you want to use the formula? Now the formula for computing the sum of the first n squares is this one right here. So if I want the sum of the first 10 squares, that means n is 10, so this is 10, times 10 plus 1 is 11, times, put 10 right here, 2 times 10 is 20, plus 1 is 21, all of that divided by 6, and that will give me the sum of the first 10 squares, which equals 385. So that's what these are. These are shortcut formulas for computing certain sums. Now they're only good for these particular things, the sum of the first n integers, sum of the first n squares, or the sum of the first n cubed. Some of the other sums that we've done already, you've got to either do by hand, or in another section we'll do some formulas for arithmetic or geometric series. Now, besides the summation rules, there are some summation properties that look kind of strange. So to explain a couple of these properties, I'm going to do examples with you. So this first one right here says for I equals 1 to n of just c. Now remember, c is a constant. So it's looking at this. I equals 1 to 40. My, quote, formula is just let the number stay 5. So that means the first term is 5, the second term is 5, the third term is 5, etc., all the way out to writing out 40 of these 5s. Well, that's a whole lot of writing out, but according to this formula, all we have to do is multiply n, which is this number that's at the top of the summation, times the c, which in this case is 5. So 40 times 5 is 200. So anytime you see something like that, let's say I equals 1 to 20 of just 6, there's no letter, there's no x, there's no y, there's no I. It is just asking you to add 6 up 20 times. The formula says 20 times 6, which is 120. Now the next property is this one right here. This says for I equals 1 to n of c times a sub I. Now c is a constant. A sub I would mean this. You put 1 in for I, you put 2 in for I, etc. So I've made up an example right here for I equals 1 to 22 of 2i. This property right here says I can pull this 2 out in front and do 2 times the summation of I equals 1 to 22 of just I. Now what is that? That's this right here. This is the sum of the first 22 integers. So 2 times the formula for the sum of the first 22 integers. So that is 22 times 23 divided by 2. This is 2 times, do what's inside the parentheses, 22 times 23 divided by 2, which is 253. Multiply that by 2, and we get 506. So that is an example of using the second property. So we're putting the properties together with some of these summation rules. Now these two, I think, are pretty standard. This says the summation of adding two things up can be separated into the summation of one plus the summation of the other, and this is just the same property for the quotient. So this example right here, I'm going to split this up using several of the properties. So first, I will write this as the summation of I equals 1 to 6 of I squared plus the summation of I equals 1 to 6 of 3I plus the summation of I equals 1 to 6 of 5. Well, this is the sum of the first 6 squares. I'll use that formula in a second. This one is not totally simplified yet. That 3 right there can be brought outside here. So my properties will simplify this into the summation from I equals 1 to 6 of I squared plus 3 times the summation of I equals 1 to 6 of I plus the sum of I equals 1 to 6 of 5, which is what I've got written here again, and I've also got the summation rules written in front. So I need to simplify each of these things out. This right here is this formula here, which is the sum of the first n squares, specifically the first 6 squares. So this is going to be 6 times 7, because 6 plus 1 is 7. Put 6 in here. 2 times 6 is 13 plus 1. 2 times 6 is 12 plus 1 is 13. Divided by 6. Do the arithmetic, and that's going to work out to be 91. So that's my summation for that first part. This one here will be 3 times. This is a summation for the sum of the first 6 integers. So my formula would be 6 times 6 plus 1 is 7. All of that divided by 2. And that will give me 63. This is the property that if we're adding up 5 6 times, this is just 6 times 5, which is 30. So if we add all of those up, that will give me 184 for that summation. Of course, the long way to do this would be to plug in 1, 2, 3, 4, 5, 6 into this and get that answer. 1, 2, 3, 4, 5, 6 into this and add that up and get that answer. And this would be to write out 5, 5, 5, 5, 5, add all those up to get that answer. So the formulas here are just shortcuts to having to write these out one entry at a time.